Hello, 10th period CPM. Happy day! Here's the notes. I will do my best job to go through them and give you a chance to pause. Without going too long, who knows? Um, Here we start off with a hair dryer that requires 225 watts when it is switched on. We are also given a conversion here at the end because this unit is about conversions, or this portion of the unit. And we're asked to ask the rate per kilowatt hour. So if we're going rate, so we're going to put on, we're starting with watts and we want it per kilowatt hour. So we're going to start off with 225 watts. And I like making a little T chart. I need to change it into kilowatt hours. So I have 1 kilowatt hour is 1,000 watts. Now, originally, as we taught this, last year it was all non-calculator, and we did this year. I'm going to show you how to do it non-calculator, but on our tests, as of right now, you will be doing it with a calculator. The only thing that you're going to be doing non-calculator is working on the ALEKS and only doing a calculator when they give it to you. So a quick reminder is when I take 225 over 1,000, you just end up with kilowatt hours. You want to take and move your decimal place to the left 3 times. So if I'm doing it non-calculator, I move my decimal point from here to 1, 2, 3, and I end up with 0.225 kilowatt hours. And that's all you need for that problem. So a kilo means 1,000. That's why you ended up with 1,000 watts. For number 2, if I'm having this scenario, I want to know the cost to run this particular hair dryer for an M minutes at a cost of D dollars per kilowatt hour. I would take my value, 0.225, times it by the number of minutes it runs, and then I'll multiply that by the cost. So for the dollars per kilowatt hour. And this is what the equation would be, or the expression would be. What is the cost? It would take and multiply that together. So how much would it cost to run a dryer for 5 minutes at a cost of 20 cents per kilowatt hour? And here we go. We're going to go again. I'm going to put my 0.225, multiply it by 5, and then multiply that by 0.20. The easiest way to do this when you're working non-calculator is take 5 times 0.2, which is just plain old 1. And if you've forgotten how to do that, you go 0.2. I can drop off that 0 times 5 by hand. That's going to be 10. And then I move it over 1 decimal point to just get plain old 1. So that means the cost is going to be just 0.225. Because 225 times 1 is just plain old 0.225. But that's money, so I'm going to take, it's going to be approximately 0.23, because I'm going to round to the nearest dollar, which is 23 cents per kilowatt hour. Final answer. All right, moving down to the next problem. You're doing conversions of feet into meters, or meters to feet. So I would like you to try to set up the problem. You can pause the video here and just see if you can set up the problem on your own, and then you can come back and check in. All right, so now you're unpausing. So you're going to go 25, hopefully you're at 25 meters. Tee it up, put 3.2 0.28 feet over 1 meter. So then, for those of you like to do long multiplication, this is non-calculator. Go 3.28 times 25, just to remind you how to do this problem, like if you're doing it on ALEKS. I take the 5 times the 8 and get 40, carry the 4. 5 times 2 is 10, add the 4, carry the 1 because that's 14. 5 times 3 is 15, and I get 16 here. You need a placeholder when you multiply by the 2. You might not remember that, but you do need a placeholder. And then you're going to add, multiply 2 times 8 to get 16, carry the 1. 2 times 2 is 4, add the 1 to get 5, and 2 times 3, which is 6. And then you're going to add these numbers straight down together. And I need extra space. So I'm going to get 0, 10, carry the 1, 11, 12, carry the 1, and then 6, 7, 8. So I get 82, and I need to move that decimal place over because of the 2 spaces after the decimal place. So you move the decimal place, 1, 2, to get, that's going to cost, not going to cost, that's going to be 82 feet. In this next problem, and you can pause and do it on your own first, you're going to be converting this room that's in meters to feet to find the length of each side. So you have to do that for all 3 measurements of the room. So since you have 5 meters and you want to take and change that into feet, you take 5 meters and multiply by 3.28 feet over 1 meter, because you're going to get rid of the meters in this case. You take 5 times 3.28. I like to go 3.28 and write my 5 in the bottom if I'm doing it by hand. 4, carry that, 14, carry the 1, and then 15, 16. So it would be 16.4 feet for one of the measurements. The one with 10 is very straightforward, 10 meters times 3.28 feet. And you only move the decimal place over once because you're multiplying it by 10. So you get 32.8 feet. And then for the next one, you're going to do that for the 2 meter side. And you're just going to take 2 meters times 3.28 feet. And you can do that by hand by multiplying the 2 times the 8 to get 16. Carry the 1. 2 times 2 is 4. That's 5. And then 2 times 3 is 6. So 606.56 feet. You move the decimal point over to get your final answer. Down here in our final problem on the page, for example, you're doing that Starbucks cup of coffee and you want to know it's an 8-ounce cup and it costs $3.25 for 8 ounces, and 1 ounce is equivalent to 29.57 milliliters. So the first thing you're going to do is check how many milliliters in the cup. You can go 8 ounces and convert that to milliliters. So 1 ounce is 29.57 milliliters. I need to do my work on the side when I'm doing it by hand. But you'll notice that I'm writing it over here. You just multiply that out. 56, carry the 5, 40, 5, carry the 4, 72, 76, carry the 7, and then 16, add the 7 to get 23. So then you move your decimal place over twice to get 236.56 milliliters as your final answer. I did the eraser on accident. Okay. So how much does each milliliter cost? Well, then you have to decide, and you need to try to do it on your own first. In order to do that, you want to do cost dollars per milliliter. So the dollars go on top. You know that's $3.25. And then the milliliters go on the bottom. This one's fairly ugly to do without a calculator, so I would grab a calculator when you're doing that. And you're going to get 0.013. So it's about a penny, 1 penny, 0.01, 1 penny per milliliter. Per milliliter. So very little. Okay. On the back side, I'm going to leave most of it to you, but I wanted to set you up with one of the problems that I have found in the past is our most challenging. And that's a real world problem about plastic bottles that are bought in the United States. Each day, about 140 million plastic water bottles are bought in the United States. So that's the number of plastic water bottles. Each bottle is about 0.25 meters long. And the equator of the Earth is about 40 million meters around. So you want to set that up. I'm going to have you pause and try to set it up first on your own. And then I'm going to welcome you back. Okay, the first thing I would do was put in, I need to have bottles on top because that's my start. And I want to know how long is it going to take to get around that Earth. So if I know that 140 million plastic water bottles are bought, and that I know that one water bottle is 0.25 meters long, and I know that the Earth, one time around it, is 40 million meters. I'm going to put that down here, 40. Then I'm going to simplify. I suggest right here is getting rid of some of the zeros because it even makes it easier in your calculator because you can get, since it has equal number of zeros on top and bottom, you can get rid of this one and this one. So left with 14 right here. I'm going to highlight my 14. You're left with the 0.25 meters. You're left with a 4 down here, and then the 1 and the 1. So that's what I would now do to finish this problem off, because you can get rid of all the zeros as long as they match up on top and bottom. You can get rid of all those zeros, and it's kind of nice, makes it a little easier to deal with. And I'll let you finish it up and check the answer in class. Good luck. Have a good rest of the day. Finish up this worksheet, turn it in. Actually, make sure you also do the problems that are up to this point. Have a good day. Bye.